Alrighty. In this video, we're going to be covering experimental probability. So that's the second topic we're covering after theoretical probability. So if you didn't watch the theoretical probability video, you're going to want to go back and watch that one first so you understand what we're doing. So experimental is probability that is based on the results of experiments, and they can be used to predict future results. So it's the number of times that the event actually occurred out of the total number of trials. So we're doing fractions again. So it says Lynn and Dawn tossed a coin 60 times. So that's your number of trials. And they got heads 33 times. What is the experimental probability of tossing heads using the results of this experiment? So heads is the favorable outcome. Remember, that's the one that you want. Okay, out of the total number of times that you tried. So we got heads 33 times out of 60 times. And so remember, whenever you have a fraction, you always have to reduce it. So you can type 33 out of 60 in your calculator, and that'll reduce it. But they're both divisible by 3, so it's 11 out of 20. Okay, 11 out of 20. And then if they ask you to, you can turn that to a decimal and get a percent. But for theoretical, we're just going to stop at fractions. Okay, so now the next one here, example 2, you're going to have to write a little small on this. We're going to actually use theoretical probability and compare it to the experimental. So it says a spinner was spun 20 times. The results are shown in the table below. Which color on the spinner has the same experimental and theoretical probability? So same theoretical and experimental. So first we've got to calculate the experimental. So there were 20 trials. So for red, it was 7 out of 20. And you can't reduce that, so that stays the same. White, it was 5 out of 20. And you reduce that and it becomes 1 out of 4. Okay, blue, it's 4 out of 20, and when you reduce that by putting it in your calculator, you get 1 out of 5. Okay, and then yellow, again, it's 4 out of 20, so it reduces to 1 out of 5. So these are the probabilities based on the experiment that we did. Now we're going to actually look here, and we're going to figure out the theoretical probability. So each section of the spinner is the same size, and so they're all, it's fourths, okay? Total possible outcomes is 4, and each is 1/4 of the circle. So red has a probability of 1/4, blue has a probability of 1/4, same thing for yellow, same thing for white. So now we need to look and see which one of the experimental probabilities was the same as the theoretical. So 7 out of 20, no, not the same thing as 1/4. 1/4, well, that's the same thing as 1/4. And so we look. Which color had that probability? White. So white had the same theoretical and experimental probability, but blue did not and yellow did not. So that's the gist of experimental probability. So we'll go ahead, we'll take a look at our homework here in a second. Okay, so let me pull up the homework. All right, so the first section is very easy. It says you roll a standard number cube 8 times. The results are shown below. Find the experimental probability of each outcome. So for this one, it says rolling a 5. So all you got to do is count the number of times that 5 shows up in your list and put that out of the total number of times that you rolled the die. Same thing with the other ones. So that's 1 through 8. Number 9, it says, what is the experimental probability of rolling an odd number on a standard number cube? So that's the first part. And it says, for 50 rolls of the number cube, predict the number of rolls that will result in an odd number. So basically, all you do is find the probability of rolling an odd number, okay? And then you would multiply that by 50. So you have to first find the probability of getting an odd number, and then you have to give me the answer when you multiply it by 50. So, and then question 10, same thing, just you're looking at the experimental probability and the theoretical probability, very similar to the example that we did. So all these, we've done problems exactly like it in the examples. Only thing that was a little bit different was number 9, which I just showed you. So that right there is experimental probability.